Right, so second section we'll look at is 7.3. As I said earlier, we'll learn a few shortcuts. They're basically like patterns to look for, things that allow you to just cross some stuff out. And then the last thing we'll look at is how we can take logs that are separate and combine them. So it's kind of like combining like terms. Okay, so I'm going to show you 4 different properties. Some of the properties I'll explain why it's true. Some of them I'm just going to give you the property. But these properties are just patterns. Okay? There's no work or anything you need to do. It's a special pattern you need to look for. And when you have the pattern, you can cross stuff out. All right, so here's the first one. It says a to the log base a of m. So this is an exponential expression. I know it has a log in it, but really it's a base and an exponent. It's a to a power. There just happens to be a log in the power. Well, when that happens, as long as that base or that number and that number match, you can basically cancel out. You don't cross this out because you need to see it in your notes, but you can cross out everything that's there, and the only thing that's left is m, and that's the answer to the problem. Okay, and that works as long as the 2 things I circled in red are the same. Okay, so when we do a problem, you'll see there'll be numbers, and a problem would look something like that. You don't have to write that yet. I'll give you all the properties first, and then we'll do it. But the idea here is because these numbers match, we can cross out a lot of that, and there's only going to be one thing that's left, and that would be the answer. If you change one of those 2's to a different number, it doesn't work. Okay, they have to be the same. Okay, so that's our first property. Second property. The second property is a log equation. There's your base. There's the thing you're taking the log of. We call that the argument. And there's what's on the other side. Okay, so that's a log equation. The idea here, very similar to the last one. As long as this and that match, you can cancel out everything that's right there, and the answer that you get is whatever that exponent is. But the key is those 2 things have to match. So that would look something like this one. You have a log. That base matches that base. Because they do, they cancel out. And the answer is whatever doesn't cancel out. And again, we'll go through and do that in a second. All right, so for this one, what I'm going to do is I'm going to write down why it's true. Okay, so we have an equation in log form. What can we do with an equation that's in log form? We can change it to what? Exponential. If I change, I'm just going to move this off. If I change rule 2 to exponential form, you'll see very easily why it's true. All right, Eric, what's my base here?
A.
Yes. That's my base right there. So I'm going to write A. Haley, logarithms always equal what kind of number? You want to help her out? What does the logarithm always equal? Always equals what?
It always equals the same as the exponential.
Can you give me one word? It equals the... Not sure? Exponent. Right? Logarithm always equals the exponent. So I just used my base. I just used my exponent. Molly, what's the only thing that's left? The argument, exactly. A to the r. And that would go on the other side. So if I change that to exponential form, I get a to the r equals a to the r. Is that true? Yeah. That's just saying that something always equals itself. Of course. That's the reflexive property from geometry. You probably didn't see it written as a log rule in geometry, but that's basically what it's saying, that something is always equal to itself. That's why you can cross this out and get the answer that you do. All right, let's look at third rule. This one says that the log of 1 is always 0. Doesn't matter what the base is. The log of 1 is always 0. Okay, and we're going to look at why that's true. And once I rewrite it, you'll hopefully remember something from Algebra 1 that is the reason why this works. Alex, what's my base here?
A.
Yep, so I'll circle them as I use them. So that's my base, A. What about my exponent?
0.
Yep, there's my exponent. And the only thing I haven't used
1.
is the argument. So the reason why rule number 3 works is because anything to the 0 power is 1. It's a basic property from algebra. So anything to the 0 power is 1. So on the right, that's just the reason, that's the explanation why this rule works. Okay. But the rule itself is what you really want to know. Right, and this one. Okay, we had one in the homework like this, okay, and I showed you one way to do it. I think it was this one. Log base 8 of 8 equals x. I think Emily had asked me about it, and I said, well, change it to exponential form, and you get this, and then you could figure out 8 to the first power is 8. Well, it doesn't matter what these numbers are. If they're both the same, the answer is always 1. Log base 7 of 7, log base 2 of 2. As long as these two numbers match, the answer is always 1. Okay, let's change that to exponential form and see why that's true. Connor, what's my base? Yep, can you tell me which one though?
The one on the bottom.
The one on the bottom. So there's my base. How about Zach? What's my exponent?
8.
So logarithms always equal the exponent. So when I ask logarithm always equals what kind of number, it always equals the exponent.
1.
So in this case, the exponent is 1. Right. So we get a to the first equals, and what haven't I used, Emily? The other a, right there. So what this property is saying is if you raise anything to the first power, it doesn't change. You get itself. This is how you've probably seen it before in algebra. This is how we can write the same rule using a log. Any questions on that one? Okay, so I'll give you some problems and we'll see if we can identify which rule the problem is from and then simplify it. Okay, we've already done the first couple. I kind of walked you through them already. Cameron, what rule is this example 1a?
Oh, the first rule.
Yeah, it's the first rule. It's an exponential expression where the base on the log matches the base on the exponential. So if you simplify that, what would you get for an answer?
Pi.
Pi. The answer that you get is whatever's sitting right there. Pi. Again, no work, really, calculations to show. It's just a pattern you need to look for. Okay, B. Now, what rule is that one? Yeah, that's the second one. Because we have a log, and then the base on the log matches the base inside the argument. Base matches base. So what if I simplify it using that rule? What would I get?
0.2 to the fourth.
So looking at rule 2, what does it say that all that simplifies to?
R.
It simplifies to r, which is whatever is right there.
Negative 4.
So in this case, negative 4. And the reason behind that is the reflexive property. Something is always equal to itself. Not as obvious to see that property when you write it as a log rule, very obvious when you change it to exponential. Let's try this one. The ln of e to the kt. Yep.
Wait, it's 0, right?
So if you were taking the log of 1, if you had the number 1 in there somewhere for an argument, then it would be 0. This one's a little different. Anyone think you know what rule it is? Yeah.
It's rule 2.
It is rule 2. Can you rewrite that so it's a little more obvious that it's rule 2?
Log base E
Yes.
instead of ln.
Change ln to log base e. Now write the rest of the problem. It's rule 2 because you have a log, and the base on the log matches the base on the argument to the log. So what would you get if you simplify that using rule 2?
KT.
Yeah, k times t, whatever that is. If we knew k or t, we could do that. Let's do another one. Okay, log base 12 of 12. What rule is that one?
Isn't that the fourth?
Yep, that's the 4th rule. And if I simplify it,
Just be 1.
the answer would be 1. Yep. Anybody need to see an example of the 3rd rule? Right, so those are just special patterns that if they come up, kind of give you a little shortcut to simplify stuff. All right. So the second thing we'll look at is how to combine logarithms that are separate. Or if you want, you can take a log that's already combined together and you can separate it apart. It's generally easier to combine things together rather than split them apart. Okay, so here's our first property. And you can start what's on the left and turn it into the right, or start with what's on the right and turn it into what's on the left. It works either way. What this says is that the log of a product is equal to the sum of the individual logs. So the log of a product is equal to the sum of the individual logs. And so there's an example just showing you with numbers. Okay, the log base A of 4 times 5 equals log base A of 4 plus log base A of 5. Notice, whatever the base is to start, that's the base when you split it. The base never changes. The base stays the same for this whole process. Now there's 2 bases I can do on the calculator easily. Anybody remember what are the 2 bases I can do on the calculator? Yeah?
Isn't it the natural log and log 3?
So I can do natural log. I have a button for that. That's the ln. And I can also do
Log 10.
log common log. Yep, base 10. I'm going to demonstrate this for you with base 10 because it's just easy for me to do. So I'm going to take log of 4 times 5. Okay, that's what I get. And now I'm going to type it in on the right. Log 4, and again, I'm using base 10, plus log 5. You get exactly the same thing. What's another way that I can get 20 as multiplication, besides 4 times 5?
2 and 10.
I could do 2 and 10. So you could also write it as log 2 plus log 10. You get exactly the same thing. Any way you can factor the number 20, you can split it as a sum. Any questions on that? Just remember to keep the base the same through the whole problem. That base never changes. All right, so our first rule was for a product, and a product turns into a sum. Our next rule is going to be for a quotient, division. Does anybody have a guess what division turns into?
Subtraction.
Yeah, it turns into subtraction. What's important here is now it's the order. Okay, when you add, order is not really important. 2 plus 6, 6 plus 2, same thing. Subtraction, big difference. So the log of a quotient equals the log of the numerator minus the log of the denominator. The base stays the same for the whole problem. I didn't fill in a base because I want you to understand the base can be anything. Base 3, base 7, even base E. So you can do this with ln's. Okay, base can be anything you want. Okay, so here's an example with numbers. I'm not going to type that one in, but if you want to check it, you could check it. It works. And that's our second property. Okay, third and last property. So the third property is, it's kind of like rule 1. Okay? But the difference is, let's pretend that all those were the same. Let's pretend we had like y times y, or even more, let's do y times y times y. What's a shorter way of writing y times y times y? It's y to the third. And I want you to keep that in mind. And then when we get a final answer, you're gonna notice something. Okay, so we have a log of a product. How did we just say that a product splits? As a sum or a difference? A sum. And this time, it's going to be a sum not of 2 things, but 3 things. Okay, you can use however many you have multiplied together. That's how many sums. So we're going to have 3 things we're going to add. Log, log, log. What's going to be the base on each of those logs? Yep. It's going to stay A. The base never changes through the whole problem. A, A, A. What's my first argument going to be? Yep. Y. How about my second argument? Y. And the third argument? Y again. So I have log base AY plus another log base AY plus another one. So how many of them do I have?
3.
I have 3 of them. I have 3 of the log base A y's. And what I just did there is I'm showing you an example of rule 3. Does anybody see how we can get from this to that in one step? What ends up happening? Yeah.
Check the exponent, put in from.
Exactly, that's the third rule. You are allowed to take exponents and move them in front. And the reason, I just went through and showed you. Okay. Okay, so here's an expression, log base a of m to the r. You're allowed to take the r and put it in front. So rule 3 is really like rule 1, where you're multiplying the same thing over and over. So there's an example with numbers. Okay, so any question on that rule with exponents, moving exponents in front? That's going to come up a lot when you have something. Does anybody have that rule? This. You might look at that and be like, how does that have anything to do with exponents? There's an exponent there. It's hidden. It's kind of like saying there's a base here. It's hidden. You have to remember what you're looking for. Does anybody remember what a square root, how you can write it with an exponent? Instead of taking the square root of a number, you can raise it to this power, and it's the same thing. Yeah?
Is it 1/2?
It's 1/2, yes. So rule 3 is usually going to come up in a situation like that. You're going to have a hidden exponent that you need to move in front. Bless you. And you can do that with any root. If you had a cube root, it's a 1/3 power. If you had a 4th root, it's a 1/4 power. You really, for this kind of problems, you're only going to have to deal with square roots, which are to the 1/2 power. Okay, so we'll get to one of those later on, but just keep that in mind. Okay, so the directions on the test and in the homework for this kind of problem will say, write each log as a sum or difference, express powers as factors. Okay, what that means is if you have an exponent in the problem, which this one doesn't, but if you did, put the exponent in front. Okay, so let's see if we can put this as a sum or difference. Irene, is this going to split as a sum or difference?
Sum.
Sum. Because inside here, we have multiplication. So we're going to have 2 logs. Rudy, what's going to be the base on each of the logs when I split them? 4. It's going to stay exactly the same as the original. 4. 4. Orion, how about my first argument?
3.
Yep, my first argument is my first factor. And Katie, my second argument?
X.
My second factor. And that's it. There's no exponents, so you don't have to worry about that in this problem. Okay, any questions on that? All right. Let's try this one. So when there's multiple rules involved, you always want to do rules 1 and 2 first. Moving exponents in front, that happens at the very end. So first thing I want to figure out, does it split as a sum or difference? Mason, will this split as a sum or difference? It's a sum. Even though there's an exponent, it's still something times something. Who cares what the somethings are? We'll deal with it later. It's going to be a sum. How about, Alex, what's going to be the base on each log?
2.
Yep, base 2. Base 2. And Peter, my first argument?
5.
5. And Haley, my second argument. Not 0. What were we doing a product of? 5 times, not 3. In the original problem, what does it say? 5 times r to the third. That's my second argument. Okay, that's my factor. I did 5 times r cubed. Okay, so r cubed goes here. So Eric, based on the directions, can we leave our answer like that? No. Because they said express powers as factors. That means move the exponent in front. So where would I put the 3, Eric? Would I put it in front of the whole thing or just in front of the second log?
From the whole thing.
Not in front of the whole thing. Just in front of, it just moves in front of that log. Okay? Because if you put it in front of the whole thing, it's kind of like saying you'd have a 3 that would be distributed to both of them, but the 3 was only part of the second one. It wasn't part of the first one. So we end up with log base 2 of 5 plus 3 log base 2r. Let's try this one. Log base 9 of x divided by 2. Becca, how's this one going to split?
No, some I can't remember the word. The other one.
You can give me think of a different word for it?
Subtraction.
Subtraction, yeah, it's going to be subtraction. Yep. So it's going to be 2 logs. How about Connor, what's going to be the base on each log?
9.
Yep. Base 9. Base 9. Emily, my first argument. X. And Irene, my second argument. 2. First argument is the numerator. Second argument, denominator. And that's it. Any questions on that? All right, so we've done it with all different bases. The base doesn't matter. Just keep it the same. Base 4, base 2, base 9. What base am I doing now? It's not written, but it's hidden there. Yeah? Yeah, we're doing base E. You don't have to write log of E. You can just write ln. But you should know what base you're using. You're using an E. Anyone think they could tell me the final answer for that one? How the whole thing splits, if there's any exponents, put them in front. The whole thing. Yeah, Peter?
3 ln y minus ln base, or ln 8.
Yep. So it splits as a difference because it's a division. And then when you do the division, you'd have y cubed as an argument, and you gotta put the 3 in front. Okay. Any questions on that one? So after you've done a lot of them, even if they start to get complicated, really, you can do most of them in one step. Okay. Okay, let's try this one. Okay, so it's a few things going on here. Well, there's division, right? You have something divided by something. So let's start with that. Okay, so anytime you have division, split that up first. Faith, how does division split?
Subtraction.
Subtraction. Log of the top minus log of the bottom. So log of the top minus log of the bottom. now I've got a few things going on. There's a little bit of work to do with the first part, but then in the second part, we have a product. It's the log of something times something. Well, that can be split again, okay, because it's a product. All right, so we were talking about the square root. Now the directions said express all powers as factors. Well, if you look at the problem, at first it doesn't look like there's a power in that problem, but there is. That's a power right there. What power is the square root hiding? Yep.
1/2.
1/2. So really, all of this is to the 1/2 power. Now, so I don't have to write the whole thing twice. I'm going to do it in this step. What can I do with the 1/2? Where can I put it? Yeah,
In front.
I can put it in front. So on the test, if there's a problem with a square root, the directions say to write all powers as factors, and you leave the answer with a square root, that's going to be wrong. Okay, you have to remember that that square root is to a 1/2 power. Okay. Just write that down on your reference sheet. So the first log is done. There's nothing else I can do with it. Second log, it's a product. Paige, how does a product split? As a sum. So I'm putting brackets because I'm subtracting this whole thing. I'm about to split that into two pieces. I'm not just subtracting one of the two pieces, I'm subtracting the whole thing. Because that's how it is right now. That whole thing is subtracted. Okay, so that's why I put brackets. So I'm going to have a log plus another log. When I split it, Molly, what's my base on each log? A, that doesn't change. I forgot to write it down up above, but just copy it down. My first argument, my first factor. Second argument, second factor. Okay. Yes?
Could you move the 3 in front and the 4 in front?
Yes, I have to. If I stop here, that would be wrong because they said put exponents in front. So that would be my last step. And I would probably just do that in the last step so I didn't have to write the whole thing again. But if you don't, just do it now. Okay, so we end up with 1/2 log base A of x squared plus 1. I kept the parentheses around the x squared plus 1 because I want someone who reads that to understand this whole thing is the argument. If I wrote this, somebody who reads that would think that this all goes together, and then you just do a plus 1 after. Okay, that's not what we're saying. Okay, so that x squared plus 1 is all part of the log, and then we're subtracting everything else we just wrote. And that's about as hard as it can get. It's got every rule in it. You really can't get any harder than that. Any questions on that? Okay, but I guarantee there will be a problem on a test with a square root. So you have to remember to do what we just did. All right, so now instead of splitting a log apart, we're going to combine it. I think combining is easier because at each step, what you have gets smaller and smaller. With splitting, it gets worse. It gets bigger and bigger as you go. Okay, and now for here, you're just going to think of everything we just did in reverse. Okay, reverse everything we would do to get that as a final answer. Okay, so anyone think they could tell me what the first thing you would do here if you were reversing all the steps we just did? Yeah,
Make the 4 an exponent.
put the 4 back as an exponent. Yep. So that's our first step. Okay, so we have log base a of 7 plus log base a of 3 to the 4th. And if you want to do out 3 to the 4th, you might as well. That's going to be 81. All right. And now the next thing is I have a sum. How would a sum recombine? Yep. Multiplication. So we're going to combine it into a single log. The base stays exactly the same. And what would be the two things I'm multiplying?
7 times 81.
Yep. 7 times 81, which is 567. And that's the final answer. Log base A of 567. You're not always going to get all numbers in the final answer. Depends on the problem. The next one has U and V in it, so you're not actually going to have any numbers to multiply together. But in the last one, we did. Okay. Any question on example A? Okay. Let's look at B. It says 2 times log base 3u minus log base 3e. Okay, something to mention because we're just kind of getting in the habit of following the rules, but the bases have to be the same. If you had that as a problem, you can't use any of the rules I've shown you today. They're different bases. Now they're the same. Okay, so Ileana, what would be first thing I would do here?
Put the 2 back as an exponent.
Yep, put the 2 back as an exponent. So we've got log base 3 of u squared minus log base 3 of v. And Hayden, when I recombine these, how's it going to recombine? As a sum or a fraction?
Fraction.
Right, this is going to be a fraction because of that minus sign. When I recombine it, Zach, what's going to be my base? When I recombine, what will my base be?
3.
3. So my base is 3. And it's going to be a fraction. Rudy, what's going to go on top of the fraction?
U2.
So u squared, and Emily on the bottom? V. That's it. There's nothing you can do with that. We don't know u, and we don't know v. Now, sometimes, I think in the homework, they're going to say something like this below the problem. U is greater than 0, and v is greater than 0. Don't be confused by that. You can basically ignore it. They're just saying that u and v have to be positive numbers. Because if they weren't, watch what happens if you try to take the log of a negative number. If v was negative and you tried to take the log of it, you get a non-real answer, meaning imaginary. Okay? And we're not dealing with imaginaries. Okay, so we'll assume that our numbers are always positive numbers. It's not really that important. Let's try this one. So this is pretty much the hardest one you could have. But I think we could probably do it in one step. Look at the first 3. Something plus something plus something. Ryan, when I'm adding logs together, how do they recombine? Think about, it's one of those three rules. When we're adding, we recombine them a certain way, and then when you're subtracting, you do something different. We did adding.
Does it have to do with the third rule?
So here's an example of when you would, if you had addition, how it would recombine. So when we had addition there, how did it recombine?
As like log 4.
Well, the base stayed the same. And what about what's in the parentheses?
That just got like multiplied together.
It got the two arguments got multiplied together. So whenever you have addition, you multiply. So let's go back. What are the three arguments that I have here that are added? Don't worry about the one that's subtracted.
X.
Yep. X.
X 9 and X squared plus 1.
Right. You have x 9 and x squared plus 1. And since we have addition, all of those things get multiplied. X 9, x squared plus 1. Those are all going to get multiplied together. We're going to have a log in front. The base is going to stay exactly the same. Now, what about that minus 5 at the end? Yeah.
There's division.
There's division by what number?
5.
5. That's it. So we multiplied all the arguments that were added, and we divided the arguments that were subtracted. The only thing you could do if you wanted, you could distribute. So you could make the top 9x cubed plus 9x. That's another way to write the answer. If that was a short answer question on the test, either one I would accept. I would probably leave it factored. Okay. Any questions on that one? All right. So on a calculator, can someone remind me, what are the two bases we can do again? And what are those? What bases?
10 and E.
10 and E. So there's got to be a way. What if I wanted to know something like, let's look at this. What if I wanted to know the answer to log base 5 of 12? Well, there's got to be a way to figure it out, even though it's not a base 10 or E. And here it is. And this is called the change of base formula. So this is how, on the calculator, you type in something that's not base 10 or base E. Yeah. Oh, yeah. Okay, so I'm going to show you. I'm going to show you something the first time, and then I think you'll see a pattern. And as long as we see a pattern, then we'll generalize that to a rule, and then we can follow that shortcut. Okay. I'm going to put a box around what y equals. So y equals what's in that red box. When I'm done, I'm going to have another formula for y, different than that one. So let's go through and see what happens. Let's change this to exponential form first. Connor, what's my base here?
A.
A. How about my exponent?
1.
Yep. And what would go on the other side? X. Now, I'm going to do something that I don't think we've done before, but you're allowed to do it. I'm going to take the log of both sides. So you might be like, well, didn't I just get rid of the log? Yep. And now I'm going to take the log of both sides. And watch what happens. That's the log of the left. And that's the log of what's on the right. Let me try to write it clearly. Now, I wrote the log on both sides, but I didn't put a base. So what base did I just use? 10. Okay, I just took the log base 10 of both sides. Now, I have a y sitting up there as an exponent. What can I do with that y? Using a rule we just learned. Yeah.
Right in front.
I can put it in front. So now I have y times the log of a equals the log of x. And now my goal is to get y by itself. So how would I move the log of a to the other side and get y by itself? Yeah?
It would be log a times x.
So pretend like it's y times something.
Yeah, would you move the a over to the other side and make it, would it be,
Yeah, you gotta move that whole thing. That whole thing is stuck together.
divide,
Divide by?
log a?
Yeah, whatever you have, if you had a problem like that, you just divide by whatever's next to the letter, and that moves it to the other side. Okay, well, divide by what's next to the letter. And look at what I just got by itself on the left, y. I started out with y by itself in the very beginning. So I have y equals log x divided by log a. So in the very first line of the problem, I have y equals, and I have something in a box. In the last line, y equals, and then something that's different in a box. How do those two red boxes compare to each other? Like if you had actual numbers and you did out a calculation, how would what's in box 1 compare to box 2? Yeah.
One's log base a to the x, log x divided by log a.
Okay, so that's what they look like, but if you actually plug numbers in and did a calculation out, and then compared the answer you got in box 1 to the answer you got in box 2, how would the two answers compare? Why would they be the same?
Because you just rearranged everything, it wouldn't change anything.
Okay, so I rearranged everything, but what are both boxes equal to? They're both equal to the same thing. So that's kind of like saying, if I have the same amount of money as Peter, and I have the same amount of money as Emily, well, then Peter and Emily have the same amount of money, because I have the same amount of money as both of them. Box 1 is equal to y, box 2 is equal to y. That means box 1 equals box 2. So what we've done is we just came up with a formula to convert something that has a base of a into something that has a base of 10. And that's good because we can plug in something with a base of 10 on the calculator. So we just came up with a conversion. And that's called the change of base formula. That's exactly what we just came up with. I use different letters, but the log of the argument goes on top. The log of the base goes on the bottom. Log of the argument goes on top. Log of the base goes on the bottom. What you have on the left is an unknown base, base A. Could be anything. What you have on the right is base 10. Something very easy to plug into the calculator. It turns out if you wanted, you could do it with ln's as well. I would just pick one of those two to remember. Either the top one or the bottom one. That works out exactly the same. There's no difference. Okay, so now we should be able to figure out how to type in a base other than 10 or e. Okay, you have to type it in as a fraction. Right, so Haley, if I want to type that in as a fraction, what would go on the top? A little more than just the 12. What else? Log 12. Yeah. So log 12 on the top. And how about Cameron on the bottom?
Log 5.
Log 5. That's it. When you said log 5, what was the base on what you just said? Base 10. So now to figure out log base 5 of 12, just type that in on your calculator. Log 12. Make sure you close the parenthesis. That's important. Divided by log 5. Okay, 1.54. Okay, these are probably some of the easiest calculations we'll do all week. You just have to rewrite it, type it in. That's it. Just to show you, if you did it with ln, let's say you didn't want to use log, it's fine. You get the same thing. Don't mix them though. Use all ln's or use all logs, but just remember one of them. Don't try to remember both. And let's do the last one. Connor, can you tell me how I could rewrite that? Because I can't do base 3, but if I rewrite it, then I can type it in.
Log 16.
Yep,
Over log 3.
that's it. Type in log 16 over log 3. And we'll see what you get. So log 16 divided by log 3. And you should get 2.52. On that calculator, it's very confusing to type it in. If you watched me, I have to type everything in backwards. So if your calculator works that way, you'd be better off using one like that. 2.52. All right, so we looked at some properties for simplifying logs, and then how to combine and split logs, and then also using the calculator. At this point, you know everything you need to know for the test. Okay, in section 7.4, we're just going to practice using everything we already know. That's all. Okay, so homework tonight's on 485. On 7 to 15, just the odds. 31 to 33, that's all. And then 39, 40, 51, 52. And the last part, 65 to 69, is just odds. If we have class tomorrow, that will be due tomorrow. If we don't have class because of the snow day, it will be due the following day, and that'll push our test to Monday. If there happens to be a delay on Friday and we don't have class, then that would push us doing 7-4 to Monday, and we would not have a test. Unless something else changes in the schedule that I can't predict.